Alright, exam 2, problem 3. You leave your book bag sitting 2 meters from the center of a merry-go-round. And if the coefficient of static friction between your book bag and the merry-go-round is mu s equals 0.8, and your bag has a mass of 5 kilograms, determine A, the maximum static friction between your bag and the merry-go-round. Well, part A. Alright, so static friction is less than or equal to mu s times the normal force, which in this case is 0.8 is mu sub s, times the normal force is just, in this instance, the weight of your bag, or mg. So we're looking at 5 kilograms times 9.8 meters per second squared, right? And so we get the static friction is less than or equal to 0.8 times 5 times 9.8 is 39.2 newtons. Right? That is the maximum static friction, 39.2 newtons. All right. Part B. The angular velocity for the merry-go-round at which your bag begins to slide off. Right? We're going to need to determine the angular velocity of the merry-go-round which the bag begins to slide off. Well, it begins to slide off when the centripetal force exceeds this 39.2 newtons of frictional force that we have. Right? And so the centripetal force is, what is it? M omega squared r, right? It is, let me back up a second, it's m times the centripetal acceleration, which is m, and the centripetal acceleration is omega squared r. All right? So we have 5 kilograms times omega squared, right, times 2 meters equals 39.2 newtons. So we solve for omega squared. Omega squared is going to be 39.2 newtons divided by 5 kilograms times 2 meters equals, and a newton is a kilogram meter per second squared, so it's going to be per second squared. So 39.2 divided by 5, that divided by 5 divided by 2, 3.92. Oh, yes, it's 3.92 per second squared. Right? So omega, square root of that, 3.92 per second squared. All right, let's get the square root of this. And I get 1.98, all right, 1.98 radians per second. At 1.98 radians per second, your bag begins to fall off, slide off. All right, that's it for problem 3.